All right, thank you so much for joining us today. And in this video, we have three sets of problems that we are going to go through together. I have a useful information for you at the end of the video. So I just want to give that information at the end of the video. So stay here with me. Let's go through these questions together. Let's start. So we want to find the angle between these two lines, right? This and that. And then remember the formula for finding angle between two lines. Okay, so we are going to use this. Tan theta is equal to m2 minus m1 divided by 1 plus m2 and m1 absolute, right? So it doesn't matter your m2 and your m1, right? Because of the absolute, you can bring here m1 first or m2. The absolute will take care of whether it is minus or positive, right? Don't forget m2 and m1 are the slopes, right? So this m1 and m2 are the slopes of the line, right? They are the slopes of the line. So what we just need to do is now we need to find the slope of this line and then the slope of this line too. And then we just plug them in here and then we find for the equation. We find for the angle between these two lines here. So what is the first thing that we need to do? Let's try and write this one in the equation of the line, which is in the form of y is equal to mx plus c, right? Where our m here is the slope. So that's what we need to do. We need to write this in this form so that we can pick out the slope, right? So let's assume that the first line is, let's say, line L1, which is ax plus by plus c is equal to 0. So let's form this in this. So what are we going to do? We are going to have by is equal to, then I move this and this to the right. So this is positive, goes here, become negative, the same thing to this one too. So I'm going to have minus ax minus c. Now remember here, y is standing alone, so I need to make sure that y is standing alone here. So y is going to be minus a divided by b, x minus c divided by b. And since this one is L1, let's assume that this is my slope M1, which is minus A divided by B. Right. So that's the first slope. We need the second slope, which is M2. So let's try and then write this one to, right, in the form of this so that we can now figure out the equation. So let me just bring this one here. So now L2 is a minus bx plus a plus b y plus d is equal to 0. Same thing here that we want to do. So a plus by is equal to minus a minus b x minus d, right? So I just move this to the right, this also to the right, to become minus minus. Then I divide through by a plus b. So I'm going to have y is equal to minus a minus b divided by a plus b, x minus d divided by a plus b. So here it means that m2 is equal to minus a minus b divided by a plus b. Good. So now we have our slope, this and then that. So we can just plug them in here and then we find for theta, right? So theta is going to be the angle between these two lines, right? So let's just do the substitution and then we just get it from there. Good. So now let's see what we are going to get. So now tan theta is equal to absolute. So as I said, this you can bring m1 or m2, but since we were using m2, we can write this one as minus a minus b divided by a plus b minus a over b, right? Divided by 1 plus minus a minus b divided by a plus b, all times minus a divided by b, absolute. So remember, this is kind of the formula that we are using, m2 minus m1 divided by 1 plus m2 m1. Right. So m2 is this, which is here, minus m1, which is also here, then divided by 1 plus m2 times m1, which is also here, the same thing. So what we just need to do is, let's try and simplify this and see what we are going to get. Then we can now find for theta. So this is going to give us something like this. Interesting. So like, let's find the LCM here, right? So that we can use to solve everything there. So basically what I will do is, I will just pick the top, simplify, pick the down, simplify, and then when you are done, we just put it there. So let's do that. Now minus a minus b divided by a plus b. So this, when I multiply, I'm going to get plus. So plus a divided by b, right? So let's try and find the LCM. If we are not finding the LCM, we can do something like this. I have something that I used to work with my fractions. So I have it in this form, like this, and like that, right? So this is my shape for my fractions. This is the first, this is the second, and this is the third. So when you look at my shape for fraction, you see that this side is the first, followed by second, and this is third. So the idea is this times this. This is the first, and then this is the second, and then the denominator is the third. So it means that this is going to be equal to, now this times this, which is the first. So I'm going to have minus b a minus b plus, this is the second. So this times that. So I'm going to have something like a plus b divided by, this is the third, right? So divided by the third, which is this one. So I'm going to have a plus b times b. Wow, interesting. And in other words, if we want to use the LCM, if we want to find the LCM will be this times that, which is going to be this. This will cancel this, will be left with b times this will give us this. And then this cancel this, it will be left with this times it will give you this. So the best way to do this is just using this sign here. So let's try and simplify this and see what we are going to get at the end of the day. This is going to give us something like this. So let me change something here. Yeah, so let me change this one to horizontal. Good. So this is going to give us something like this. So let me try and expand this. So we are going to have minus ab plus b squared plus a squared plus ab. Is that right? So that's what you're going to get at the end of the day. So this is going to be divided by, I'm not going to you know expand the denominator. I'll just write it this form, right? But the question is, how can we do this? Can we have a way of doing this kind of? Okay, so let us leave this in this form, right? Let's just leave it in this form. Let's try and work on the denominator too and see what you are going to get, right? So this is the numerator. Let's try and work on the denominator. So denominator is 1 plus, I'll multiply this and this. So minus minus will be positive. So I'm going to have a minus b divided by, then when I multiply this and this, I'm going to have b a plus b, right? Good. So don't forget, this is kind of divided by 1. So if I'm using this shape, first, second, third, so this will multiply this, and then this will multiply this divided by this times that. When you get used to it, it becomes very simple. So this is going to be b a plus b plus a minus b divided by b a plus b. You get it? So this times this is here, and then plus this times this is also here, or divided by this times that is also here. So let's see something. Since this is of the form that, then even it's best for us to leave it in this form here so that we can do some cancellation here, right? Yeah, we can do some cancellation here. So now what we are having is, okay, let me try and expand this one too and see what we are going to get. So this is going to be giving us ab plus b squared, right? And we are going to have plus a squared minus ab divided by ba plus b, right? So I expanded this. This is ab, b squared, a squared minus ab, what is here? So this is the numerator, this is the denominator, right? So let's try and put them in. So the top is giving us, so we are back here to our equation here, right? So the top here is giving us something like this. So let's try and put it there. So we are going to have something like minus ab plus b squared plus a squared plus ab divided by ba plus b, right? So that's what we are going to get for the top. So the top, this is what we had. So this is what I have here. Divided by, so since I'm done with this one, I want to clean up this. Good. So instead of doing divided by everything here, I'm going to do it, this division here, I'm going to do it like this, right? So it's the same thing. So divided by the denominator. So the denominator here is what we had here, right? So that's what I'm going to put there. So let's put it there. So you should be able to be doing this very well. So this is going to give us ab plus b squared plus x squared minus ab, right? Divided by ba plus b. Absolute. Nice. Nice. So I can clean up this one too as well. And let's try and simplify. So we know that whenever something is divided and we want to change it to multiplication, the down goes top and then the top comes down. So this is going to give us absolute of minus ab plus b squared plus a squared plus ab divided by b a plus b times b a plus b divided by, so you see that now I'm moving this one top here and I'm writing this one. I want to write the top in the form of this. So we saw that minus ab first, so I'll write minus ab first. So minus ab plus, this one was followed by b squared. Let's see if we have b squared. Okay, b squared is here. So plus b squared. Followed by a squared. Okay, we have a squared also here. So plus a squared. And then followed by AB. Do you have AB here? AB2 is also here. So followed by plus AB. Absolute. So the magic will happen. We see that this will cancel this. And then this also cancel that because they are the same, right? So it means that what will be left in the absolute is just going to be left with 1. Because when they cancel out, it will be just 1. So it means that tan theta is equal to 1. Absolute of 1 is also equal to 1. So nice. What is happening here? It means that now tan theta is equal to 1. So we need to find the angle. So angle here is tan inverse of 1. And we know that tan inverse of 1 is 45 degrees. Wow. So now we can conclude that the lines, right? The lines are inclined at 45 degrees to each other. So that's the conclusion that we can make here. So let me see if I can write best solution here for you. So let me just move this one up and write the total. So therefore, the lines are inclined at, let me try and shift this one to up small so that I can get space and write the solution for you, at 45 degrees to each other. Good. So that's what we need. This question asks us for just the angle, right? 1. So we can get to the other angle because anytime you have two lines like this, you have one angle here, you have another angle here. So if this one is 45, then automatically this is going to be 135. But since we just need one angle, at what angle? So the 45 is okay. So here, 45, the line is inclined at 45 degrees to each other, right? So, formulas, right? How to get the formulas and then how to start them are very, very important, right? So this is for this question, right? All right, let's look at question 2. I love this question a lot because we are going to go a long way of doing this. And I hope you are going to understand it and then enjoy it too as well. So one side of a square lies along this straight line here. So as I said in the first video, I mean, when I was talking about formulas, I said with this course, what we just need to do is some of the question we need to sketch before we can get, what we want to get out of it, right? So that's what we are going to do here. So we are saying that one side of a square lies along this straight line here. And then the diagonals of the square intercept at this point. So the first question is we want to find the coordinates of the vertices of the square before we even think of the B. So let's try and sketch something. So for us to sketch, we need to sketch this line. Now this line we can talk about so we have 4x plus 3y is equal to 26. So for us to sketch this is a line. So like when x is equal to 0, when s is equal to 0, we are going to have y is equal to 26, and then y will be equal to 26 divided by 3, right? So this is when x is equal to 0. So we have one coordinate 0 and 26 over 3. Then we think about when y is 0. So when y is 0, we are going to have 4x is equal to 26, and x is going to be 26 divided by 4. And I think 26 divided by 4 should be something like, I don't know, can we cancel this? I don't know. 2 can go here 2, and 2 can go into 26, 13. So we have another coordinate 13 and 2 and 0. So this coordinate here will help us to draw a straight line. We want to sketch something so that it can help us. So A, we want to sketch a nice graph here. So I have my y-axis, and then I have my x-axis. Now at this point, we have like, let me assume that 0 and 26 is somewhere here because this is like x is 0 and y is this. So let's assume that it's here. And this one x, y is 0, and then this one 2 is here. So let me assume that that point, which is 13 over 2 and 0 is somewhere here. So this one will help us to construct a line which passes through this point. Good. Very nice. Good. Good. So this is I call this is the equation, which is so let me clean the solution here. So this line here is the equation that was given to us. 4x plus 3y is equal to 26. So we've gotten one side of the square, right? But they are saying that the diagonals meet at -2 and 3. So -2 for x will be somewhere here, and 3, 2 will be somewhere here. So it means that this point is going to be in here. So we are trying to, form a square. So I think it's better for me to bring my point close so that my square will be a square. All right, so let me just remove this coordinate here, this, and then bring the point somewhere here so that I can bring this line close, right? And then I'll shift this one to the right small so that I can now draw my line. So I'm trying to draw a square. So like, let me assume that I have one line somewhere here, and then I have another line somewhere here. Good. It's not going to be perfect, but it's okay. Good. So let's assume that this is the line that I'm having. Let's assume that this is a square. Let's assume like it's a square, right? Good. So let's try and talk about the diagonals, right? So we are going to have one diagonal here, right? And we are going to also have one diagonal here. Now we are saying that they meet at intersection at -2 and 3. So it means that at this point here, at this point, we are having -2 and 3, right? So we are assuming that that is the diagonals. So we're able to form something. So the question is now we need to try and find the vertices, right? So we are assuming that this is A, this is B, here is C, and here is D. So the question is how to find the coordinates for this, that, and that. And this is very interesting. That's what we are going to do here. Now, the first thing that we need to know is the properties of square, right? So we know that square is having something like this. This is, let me form a beta square, right? Good. Oh, this is not a beta square. Good. This is a beta square. So remember, one property is they all have 90. They all meet at 90, 90, 90, 90, right? So one thing that we can see here is when I have a diagonal like this, it divides the angle into two, right? Because it's a diagonal. So here it's going to be like 45. The same thing, like when I divide. So since I have this line here, right? What I'm going to do is I want to find the slope of this line. But remember, if this line, if we know that this line here is 90, so the angle there, or let me say the angle here is 90, so the slope of this is negative reciprocal of this. But we don't need that. We want to get the slope of this so that we can use the point here to find the equation of this line. So that's what we want to do, because as soon as we get equation of this line, which is AC, we can solve this line and this line simultaneously to get the coordinate for C, because they are meeting at this line, right? So since we have this point, the only thing for us to form the equation of AC is to get the slope of AC, right? So if you can see this, we can see that we have a line, this line here. What is the midpoint? This line here, right? So on this line, we can see that we have an angle between these lines, right? So we have one line here, another line here with angle theta. Is that right? But this angle theta here is 45, because we know that when we divide this one into two, we are going to get 45. So it means that this angle between this is 45 degrees. So this one will help us to now find angle between two lines. The formula that we just used here. Angle between two lines is this. So this is going to help us to find angle between two lines. So this angle here and this angle here, right? And this one was 45. So that's what you are going to use to do that. So angle between two lines. So we want to find angle between line AC and line BC, right? That's what we want to do. We want to find the angle between this and that, which we know that it's 45. But we are using that idea to get the slope, because remember, we go with slopes, right? To get the slope of line AC. Now we know the angle. We can use this line here to find the slope of this line too. So let's do that first. So we know that this angle is tan theta, which is equal to absolute of m2 minus m1 divided by 1 plus m2 m1. Now let's try, and then we know theta to be 45, and we will get one of the slope from this line here, because BC, line BC, we know line BC to be this. That's the equation. So let's do that. Let me assume that this line is a BC line. BC has a slope of, let's say, let's name it M2, right? We can name it M12 as well. As I said, the absolute here will take care of the minus. So this is going to give us something like 4x plus 3y is equal to 26, right? So this should give us 3y is equal to minus 4x plus 26. So I'm trying to make y the subject, right? I want to write it in this form. Y is equal to mx plus c. So this is going to give us y is equal to minus 4 divided by 3x plus 26 divided by 3. So it means that since we are saying that this is m2, the slope is m2, this is going to give us m2 to be equal to um, minus 4 divided by 3. Good. So now we know the angle. The angle is 45, right? From here. And then we know one slope. So this one will help us to find the slope M1. And remember, the line AC slope is equal to M1, right? Which is the one that we are coming to look for. Good. So let's do substitution and find the angle from here. So this is going to give us tan 45, which is equal to absolute of now M2 is equal to minus 4 on what? On 4, minus 4 on 3. So minus 4 on 3 minus M1 divided by 1 plus then M2 times M1. So this is going to give us 1 minus 4 over 3 M1. Good. So now all we need to do here is we try to figure out M1 by just solving this and then checking out what we are going to get for M1. And then the game starts. Now we can now try to see what we can do. But the question is, what is tan 45? What is tan 45? What is tan 45? So we know that tan 45 is, I think, 1, I guess. Yeah, this should give us 1. Because we know that tan inverse of 1 is 45. So we are going to get 1. And then we have this one here. So look at what I'm going to do here. I have minus here, minus here. I can factor it out. So I'm going to have minus 4 over 3 plus M1 divided by 1 minus 4 over 3 M1 absolute. So the absolute will take care of the minus here, right? So that's what you are going to get from the absolute to take care of the minus. So this is going to be 1 is equal to, now when I multiply this slope, two of them together, it will be less than this. So I'm not with this one, I'm just going to leave it like that. So this is going to give us 4 on 3 plus M1 divided by 1 minus 4 divided by 3 M1. So now let's try and play around this to get M1 basically. So what I can do is I can multiply, this is divided by 1, so I can multiply this one by this and this by that, right? So let's go to the next page. Let me just try and copy this one, so because that's what we are working on, and send it to the next page. Good. So let me just paste it here, and then let's try and then get the gradient. So this is going to give us 1 minus 4 over 3 M1 to be equal to 4 over 3 plus M1. Let's group items. I'll move this to the right and move this one to the left. So I'm going to have 1 minus 4 on 3, which is equal to M1 plus, let's see what you're going to. Okay, so what we can do is, let's check something here. Here I cannot just write, I cannot just, let me paste what I just picked here. This one I cannot just pick I cannot just take off the absolute, because the slope for M1 can be in a way that this will be greater than this and to be negative. So what we can do is we can pick the positive side and negative side. Good. Because we know how absolute works. Yeah. So this one will help us to do that. So now what I'm doing here is the positive side. So here, let's assume that we are picking the positive side. So 4 plus sign. So that's what we are working on now. Good. So that we can see what we can get from here. So this one is going to be 4 divided by 3 M1, right? So now what is 1 minus 4 on 3? So don't forget this shape, right? This will multiply this will multiply this, and then we are going to have 3 minus 4 divided by 3, which is equal to, now don't forget this one too is in 1 here. So this is going to give us, when I factor m1 out, 1 plus 4 over 3. So what am I going to get? I'm going to have minus 1 over 3 to be equal to, when I add this, what am I going to get? This is like 3 over 3. So I'm going to have 7 over 3 m1. And when I multiply this by 3 and multiply this by 3, 3 will cancel 3, 3 will cancel 3. So I'm going to have minus 1 is equal to 7m1, and then m1 will be equal to minus 1 over 7. So this is the positive side. Let's try and work on the right side, right? So let's go through that. So let's try and work on the negative sign and see what we are going to get. So this is going to be minus, this is going to be minus open bracket 4 over 3 plus m1 divided by 1 minus 4 on 3m1. So I'll just multiply the minus 2 by this. So I'm going to have minus 1 to be equal to 4 over 3 plus m1 divided by 1 minus 4 over 3m1. And this is going to be, multiply this by that, and I'm going to have minus 1 times 1 minus 4 over 3m1, 4 over 3 plus m1. So this is a lot of work that we are doing here. The hard work will pay off very soon. So this is going to be minus 1 plus 4 over 3 m1, which is equal to 4 over 3 plus m1. So let's try and group like terms. I'll move this guy to this side, and I'll move this guy to this side. So I'm going to have 4 over 3 m1 minus m1, which is equal to 4 over 3 plus 1. So when I factor m1 out, it will be left with 4 over 3 minus 1, which is the same as, when I add this one, I'm going to have 7 over 3 as we did on the other side. So subtract this, and we are going to have, I think m1 divided by 3, because when you subtract, this one is going to be 1 over 3. So 7 that. So when I multiply this one by 3, multiply this one by 3, this will cancel, this will cancel. So m1 will be equal to 7. Good. So yeah, this is very nice to work with. So what we can do is, now we have a choice. Let's try and pick one of the slope, and then we just go by that. But for us to pick one of the slope, the idea is that we need to pick a slope in a such a way that when we put them in here and multiply, we are going to get the 45. So here, let's do something like, let's pick the positive one, right? So let's assume that the slope of line AC is m1, which is equal to 7. So let's use this. So good. Now let's come back here. We know that the slope for AC is now m1, which is equal to 7. So now that we have the slope, we can find the equation of this line, right? So now let's form the equation of this line. So we are now come to start the work. So we needed to go through all this to get just the slope, and then now find equation of this line. Now equation of this line needs a slope and a point on the line, which is minus 2 and 3. So let's do that. Let's try and form equation of the line. So equation of the line AC, equation of the line AC is given by y minus y1 m x minus x1. So remember, the slope is 7, and then the point is minus 2 and 3, right? From here, this is the point. So now let's form our equation, this will be y minus 3 is equal to 7x. So this is going to be minus 2. Y minus 3 is equal to 7x plus 2. Simplify and we have y minus 3 is equal to 7x plus 14. And this implies that y minus 7x is equal to, so I just move the 7 to this side, then I'll move minus 3 to this side, become positive. So this will be equal to 17. So this is now the equation of line AC. And that is when the actual work starts. So now that we know the equation of line AC and equation of line BC, we can solve them simultaneously to form or to find the point of C. So we are now coming to even work on what the question is looking from, as we want to find a vectors. So let's solve this and this simultaneously to find the coordinate of C. So this is the equation of the line for BC, and then the one that we just found was equation of the line for AC. So let's do that. Let's do that on the next page, right? So let's do that here. So line AC is having equation which is y minus 7x, which is equal to, I think, did I see 17? Yeah. And then BC is having, what is the BC? What's the equation of BC? Okay. 4x plus 3y. So I will just do it 3y plus 4x is equal to 26. So we try to solve this simultaneously to make sure that everything is fine. So what I'm going to do is I want to eliminate one of the variable. So for me to eliminate, then if I want to eliminate y, the coefficient of this should be the same as this. But we see that the coefficient of this is 3. So for me to make sure that this minus this is going to 0, I need to multiply this one by 3 so that I have this one. So I'm going to multiply this by 3, right? So let me multiply this by 3, right? This is going to give us 3y minus 27x is equal to. So now what is 17 times 3? I'm not using calculator, so I just need to do it. 7 times 3 is 21, 2. So that one is going to give us 51. Good. So now let's compare. Let me write this one again. This is 3y plus 4x is equal to 26. Let's subtract. So when I do the subtraction here, this is going to give us 3y minus 3y will be 0. Minus 27 minus 4 is going to give us minus 31x, I think, yeah, which is equal to 51 minus 26 should be, is it 31? Yeah, I think so. No, should be 21 or something like that. Okay, let me just do it here. I'm just confused. 51, 26. So this one will be 11. Subtract 11 from 6. This should be 5. And this one should be 2. Is that right? I'm not using calculator, so I'm just crazy here. Let me check my equation again. 3y, 4x, 26. Okay, that's right. And then this one that we found, we had y minus this is equal to that. So we multiply this one by 3. 3 times 7 is supposed to be 27 now. I'm not sure 3 times 7 is 3 times 7 should be 21. Is that right? Why am I so confused? 3 times 7 should be 21. Good. I'm sorry, I'm not using calculator, so kind of the mind is twisting up. So 21. So it means that this is going to be 25. Oops. This is going to be 25. So minus 21 minus 4 should give us minus 25x. And then 51 minus 26 should also give us 25. So I divide through by minus 25, divide this one by minus 25, and x will be equal to minus 1. Okay. Now let's plug in 1, negative 1 inside any of the equation, right? So if I'm picking y minus 7x is equal to 17, then I'm going to have y minus 7 times minus 1 is equal to 17, y plus 7 is equal to 17, y is equal to 17 minus 7, and this is going to give us a 10. So remember, ACBC will have a coordinate at C, right? So it means that the first coordinate that we are getting here is C is minus 1 and 10. So we've gotten one coordinate by solving it simultaneously. So we have one coordinate here, which is kind of, let me say, we had minus 1 and 10, right? So that's what we are getting here. So it means that this line here does not necessarily meet at this point, but rather somewhere. Yeah, we don't know where it's supposed to be, but it's just a sketch. So it's okay to have it that way. So we have C to be minus 1 and 10, right? Minus 1 and 10. So what we need to do is, now let's try and figure out the rest. Okay, so what can we do again? Now that we know this guy, now look at something here. We know that we can also find the equation of this line here. What can we do? We have a point, so we just need this slope. But don't forget, if I divide this into this and this one too into this, look at something happening here. This is also going to be this. And remember, this is going to form a 90 here, right? So since this is a 90, and then I know the slope of this line, then when I find the negative reciprocal of this, I'm going to have the slope of this. So you see that when I find the negative reciprocal, that's what is going to give me the slope here. That's so nice. So negative reciprocal of this guy is going to give me the other slope that we need here. Did you see that? Yes, of course. Yes, that is true. So it gave us two gradients, one for this and one for that. So now let's find the negative reciprocal of this, and we are going to get minus 1 over 7, which is the other slope that we had. So if you use, I know some of you will be like, what if I choose minus 1 over 7? Then what am I going to get? Your point will just change a little, but it's going to be the same. So when you pick this one for M1 for AC, then when you find the negative reciprocal of this, you are going to have 7 for the other slope here, which is BD, right? So now let's find the slope of BD. So we are saying that since line BD is, or let me say, perpendicular to line B is BC, no AC, then the slope of, let's say, BC slope of BD rather is equal to, or is equal to, minus 1 over M1. The M1 that we chose was 7, so this will be minus 1 over 7. So now we've gotten the slope for this line here, right? So this line here is having a slope of, minus 1 divided by 7. So since this point is on this line too, we can use this to find the equation of this line. And when we get the equation of this line, we can use this line and this line to find B because they meet at B. by solving it simultaneously. So let's do the same thing. So slope, the equation of the line AB will be given us with the point -2 and 3. So we are going to have y minus y1 is equal to mx minus x1. So y minus 3 is equal to -1/7, and then x, when I plug in the 2, become plus, so plus 2. Let's multiply through by 7. So I'm going to have 7y minus 21 is equal to minus x3. 7y minus 21 is equal to minus x minus 3. And I'm going to have 7y plus x. So I move the minus s, become plus. Then I move this guy here, become positive. So this should be minus 3 plus 21, and 7y plus x is equal to, this is going to give us 18. Yeah, that's what we are going to get. So this is equation of the line BD, right? So now this equation of the line here, which is this BD here, will help us to solve this and that simultaneously to find B. So let's solve this equation and this equation to find B. Let's go and do that. Okay, and I will need another space for that. So let's build another sheet so that we can do that. So now we know BD to be equal to, or the equation of BD to be, what do we get? 7y plus x. 7y plus x is equal to 18. And then line BC was, I think 3y plus 4x is equal to 26, right? Let me check, confirm. All right, confirm. 3y plus 4x is equal to 26. So now we want to solve this one simultaneously, right? So we want to make sure that one of the variable is having the same coefficient. So this one, let's now ignore, let's now try to eliminate x so that we can just multiply this one by 4 and they are the same, and then we just go through. So multiply this by 4, right? Multiply by 4, this will give us, and 4 times 7 is going to be 28, like this one, I hope, I'm sure, plus 4x is equal to, now 4 times 18, 8 times 4 is 32, is that right? Yes. So this is going to give us 72. Good. Then let me rewrite this one again. 3y plus 4x is equal to 26. So let's do the subtraction. 28 minus 3 should give us 25y is equal to, because this and this will be 0. So this is going to be, now 72 minus 26 should give us something like 4. Is it supposed to be 4 or 5? Okay, 72 minus 26. Borrow. This one will be 12. This is going to be 6, I think. 6. And this one will be left with 6. And this is supposed to be 2 minus 6 should be 4. Is that right with my multiplication and steps? Let me check my multiplication and stuff because I'm not good at it. Let me check my equation again. Let me see my equation here. Oh, okay. There was a nice and big mistake here. So this is supposed to be 2, and this will be 2, and this will be 2, and this is going to give us 19. Good. So that, because I remember we need to get a perfect value here. So this is 19. So 4 times 19 now is, this is kind of 36. So here will be 6. And then this will be now 76. Good. So this is supposed to be giving us 76. And then 76 minus, okay, that one will give us 50, which is nice. So this should give us 50 and y should be equal to 2, right? So I divide through by 25 and I get 2. Plug in y is equal to 2 into any of the equation here to find your x. So I want to use the first one, 7y plus x is equal to 19. So let's plug in 2. So 7 times 2 plus x is equal to 19. This will be 14 plus x is equal to 19. X is equal to 19 minus 14, and this is going to give us a big 5. Is that right? We're supposed to get 5? Yes. So we have b to be equal to 5 and 2. Solving that one simultaneously, giving us 5 and 2. So now the game gets interesting because now we have this guy, we have this guy. We need A, we need B. We don't need to do any hard work here. You see this line here? Now we have a midpoint because whenever they do, whenever diagonals meet, they meet at the midpoint. So we need to use the idea of midpoint to find this and that, right? Because since I have the midpoint here, then I can say that let D be, let's say, D be, let's say AB. So I can use the midpoint approach to find AB. And let's assume that A to be, let's say, TS, and I can use the midpoint approach for this one to find this. So let's use midpoint, this, and this to find this, and at the same time midpoint for this one too. So let's do that one, and we are done with the coordinate. We look at B, and I think this question is a whole lot. It's kind of a homework question, you know. So stay tuned. So let's look at what we've got here. So now we are using the midpoint approach. We have we said AB is ST, right? And B, we know that B is 5 and 2. We know that C is minus 1 and 10. And we are saying that D should be AB. But look at the midpoint. The midpoint goes with AC and then BD. So let's use that idea to compute that. So the midpoint of AC is equal to, remember the midpoint formula, right? X1 plus X2 divided by 2, and then Y1 plus Y2 divided by 2. So what's the midpoint of AC? We saw that the midpoint of AC was minus 2 and 3, right? So it means that that is going to give us minus 2 and 3, which is equal to, now what is the point of A? This is the point of A. What's the point of C? This is the point of C. So this is x1, y1, x2, y2. So we are going to have s minus 1 divided by 2, and we are going to have t plus 10 divided by 2. So since it's midpoint, the coordinate here is the same as the first coordinate here. The coordinate here is also the same as this. So this is going to give us minus 2, which is equal to s minus 1 divided by 2. So let's try and find for s. So this is going to be minus 4 is equal to s minus 1, and then s is equal to minus 4 plus 1, which is equal to minus 3, right? So just multiply this one by this, minus 4. Then I move this one to this side, giving us this, and we have this. Let's look at the other component. 3 will be equal to t plus 10 divided by 2. 6 is equal to t plus 10. And then t will be equal to 6 minus 10, which is equal to 4. No, minus 4. Right? So the coordinate for A, is now, we said S and T. So minus 3 and minus 4. Minus 4. So now we've gotten A to be minus 3 minus 4, right? So minus 3 minus 4. So it's left with last one, which is D, using the midpoint approach again to find for that one too as well. So I can clean up this solution so that we can get them done here. So now what we just need to do is, now let's find a midpoint approach for the other one too as well. So let me just grab the whole of this, right, and then push it to the other side. Let me say hold it and make it small, and let's put it this side. Now we want to look at midpoint for BD, right, which is equal to the same x1 plus x2 divided by 2 y1. So I hope you are still here, because I have some tips for you at the end of the video. And then this is kind of homework question, so it's kind of long. So now what is the midpoint? The same midpoint of BD is minus 2 and 3. And let's assume that this is x2, y2. This is x1, y1. So we are going to have 5 plus a divided by 2, and then 2 plus b divided by 2. So same idea, this coordinate is the same as this is also the same as that. So minus 2 is equal to 5 plus a divided by 2, minus 4 is equal to 5 plus a. So a should be equal to minus 4 minus 5, and this is minus 9. Let's do same for this guy at the other side here. So 3 is equal to 2 plus b divided by 2. 6 is equal to 2 plus b. B is equal to 6 minus 2, and 4. So it means that D is minus 9 and 4. Minus 9 and 4 for D. So that was a lot of work. Minus 9 and 4. Is that right? Minus 9 and 4. Good. So now we are done with all the coordinates. We were able to find all the coordinates, right? We've done well. So we've gotten minus 3, minus 4. We've gotten 5 and 2. We've gotten minus 1 and 10. We've gotten minus 9 and 4. So the last question on this, before we move to the last question, is the question is asking us to find the equation of side of the sides of the square which are perpendicular to the line or the given line. Okay, so perpendicular here is we need to find the equation of this line, and we need to find the equation of this line, because the question is saying that we should have the equation of the sides. So it's like more than one, but the one which is perpendicular to the line given is this one. So the one which is perpendicular to this one is this, and this one too as well. So for us to find this, now we know one point on this line. So all we need to do is find the slope of this line. But we don't need to use this point and this point to find the slope. We can use the idea that since the slope of this is equal to minus 4 on 3, then they are perpendicular to each other. We take the negative reciprocal. We used to do this, and the same thing for that one, and then we are done. So let's go and do that, and then we will be done with this video. So I think we will need another last page for this question. Then we look at the last one. So now we are looking at equation of the line AB and I think CD, right? AB and CD. Good. So you can pick any of the points, like any of the points. Now we know that the slope is negative reciprocal of that. So we are going to have 3 on 4 for the slope for this, and then the slope for this one too. So we can pick any of the points, either this, and that, or this and that, any of them, to just find the equation, and then we are through. So let's go with first the equation of the line AB. So for AB, remember the slope is going to be, as I said, what was even the slope? Minus 4 on 3. So it's going to give us 3 on 4. Then we pick any of the point. We can pick the point A or point B. Any of them will work out. So if I pick point A was, I think, minus 4, minus 3, minus 4. I think that's so. Let me check it out. Minus 3, minus 4. So the equation will be y minus y1 is equal to m x minus x1. Let's just do substitution and we are done with this. So it will be plus 4, 3 over 4, then x minus or plus 3, right? So minus 4 will be plus, minus 3 will be plus. So let's just try and simplify this. Multiply through by 4, 4y plus 16 is equal to 3x plus 3, and then 4y plus 16 is equal to 3x plus 9, and then 4y minus 3x is equal to 9 minus 16. So 4y minus 3x is equal to minus 7. So this is one equation, which is the equation of the line AB. So let's do for CD, and then we are done with this. For CD, the same slope, right, which is 3 on 4, but now the coordinate is going to change. Let's use one point, either C or D. So we can use C, minus 1 and 10. Minus 1 and 10. Let's use minus 1 and 10 to do that. Minus 1 and 10. So y minus y1 is equal to m x minus x1. So y minus 10 is equal to 3 over 4. X minus minus 1 will be plus 1. And this is going to be nice. 4y minus 40x, 40 is equal to 3x plus 1. 4y minus 40 is equal to 3 plus 3. And then 4y minus 3x is equal to 3 plus 40. And then 3y minus 3 is equal to 43. So this was a long journey, a very long journey. And as I said, this is kind of homework question. So we need to sketch everything and then write everything out. Let's do the last question. I give the tips and then we are done here. Let's do the last question here. So last question here is find the sum of x, y. Find the sum of x, y. Intercept at any tangent line to the curve. So we know tangent line, right? If we don't know, we are just learning it, and then we'll see how we can work with tangent lines. We will start circle very soon, so that one will help us to understand when we are talking about tangent lines, right? So what we are going to do is when you say tangent line to a curve, so let's assume that this here is like kind of, this is the curve, right? So the tangent line is like touching the circle at just one point, right? So let's assume that the point that we are talking about is point P, and it is P naught, Y naught. So this is the point that we are having here, right? So if we are having the point, and then remember, since this is intercepting this line here, like this is root x plus root y plus no equals root k. So when we say something is intercepting, then we can assume like solving it simultaneously. So it means that we can plug in the point inside this. So it means that we are going to have an equation which is root of x naught plus root of y naught, which is equal to root of k, right? Because we want to solve this one simultaneously. So the first point x X S naught and Y is Y naught. So we just plug it in and we have this one here. Now, what can we do? Since this one is a tangent line, basically we need to find derivative. I know maybe you may not understand how we are going to do the derivative here if we are not good with differentiation. But don't worry, we will do derivative and you understand it and it will apply here. But stay here with me and let's see how we can do the derivative here. Now, let's go. Root of x plus root of y is equal to root of k, and this is the same as x to the power 1 over 2 plus y to the power 1 over 2, which is equal to, let me say, root of k. Now we are going to use something called implicit differentiation. I know you've heard it before. That's what we are going to use. So let's do that. I want to differentiate this. What am I going to get? Power rule, 1 over 2 drops down, and then 1 over 2 minus 1. But remember, we are differentiating this with respect to with respect to x. So when I differentiate this, this is what I'm going to have. Plus, remember we are dealing with implicit. So when I differentiate y, same idea. 1 over 2 drops, 1 over 2 minus 1 times. Now because it's implicit, now we are differentiating with respect to x, so we are going to have something like dy over dx. This one, we are having something like ds over ds, but ds over ds is going to be 1. So we don't need anything there. But this one, dy over dx is not 1. And then when I differentiate a constant, I get 0 because it's a constant. Right. So let's try and figure out what we need for this guy here. Simplify this is 1 over 2 x to the power minus 1 over 2 plus 1 over 2 y to the power minus 1 over 2 times dy over the x is equal to 0. I think this is the same as 1 over 2 x to the power 1 over 2 plus 1 over 2 2y 1 over 2 times dy over dx is equal to 0. Now what I need to do is I'm going to move this guy to the right. So I'm going to have 1 over 2. Now y to the power 1 over 2 can be written as root of y times dy over dx, which is equal to, when I move this one, I'll have minus 1 over 2 root of x to the power 1 over 2 is the same as root of x. What can we do? We can divide this one by 1 over 2 root y, 1 over 2 root y. So when I do that, or let me say, I'm going to multiply through by, let me do it that way instead of dividing. Let's multiply through by 2 root y, and here 2 root y, so that this will cancel this, and we are going to have dy over dx to be equal to minus 2. Okay, so this one too, the magic happens. 2 will cancel the 2. So we are going to have root of y divided by root of x. So this is the slope, right? This is the slope. But we need to find the slope at the point. What is the point? The point was this. S naught and y naught. So x is x naught and y is y naught. So we are going to have this one to be dy over dx to be root of y naught divided by root of x naught. And basically this is the same as, we can combine them, but I think let's just leave it in this form. So why did we do this? We want to find x and y. So this kind of one equation, right? So we needed another equation so that we can solve it simultaneously to get, let's say, x and y. Or maybe since the question is talking about x-intercept and y-intercept, then we don't have any other choice is to find the equation of the line, right? So that's what comes in mind, equation of the line. So let's find the equation of the line. Oops. Okay, let me delete this one. So let's find the equation of the line. So let me open another page. Oh, basically no. Okay, so basically, yeah, definitely I need this. So the same question, but I just want to use a sheet below. So let's find the equation of the tangent line. So the equation of the tangent line is the same thing. Y minus y1 is equal to the slope. Now don't forget the slope here is dy over the x, and then x minus x1. So we are going to have y minus, what is y1? Y1 is x naught, sorry, y naught, and x1 is x naught. So we are going to have x naught, which is equal to the slope. The slope we had minus root of y naught divided by root of x naught, x minus, oops, this is supposed to be y naught, and this will become x naught. So the slope, which is dy over the x, which is m, is minus root of y naught divided by x naught, and then the point was x naught and y naught. So let's try and simplify this, and then we find s-intercept, we find y-intercept, then don't forget we want to add it. So basically we add our y and our x. So let's do that. For let's say y-intercept, what do we know about y-intercept? For y-intercept, s is equal to 0. So it means that this is going to give us y minus y naught, which is equal to minus root of y naught divided by s naught, 0 minus x naught. So that's what we're going to get. So y minus y naught is equal to minus root of y naught divided by x naught times x naught. So that's what we are going to get at the end of the day. But let's try and do some small simplification from here, and then I think we can do the idea of adding them together. So I can multiply this to this. So I'm going to have root of x naught y minus y naught, which is equal to then this to this. So I'm going to have minus x naught root of y naught. Simplify this with y, x naught minus y naught root of y naught root of, oops. So we are basically, I don't think this is a good idea. We are basically trying to find y, right? So instead of multiplying through by that, it's not a good idea, but rather moving y naught to this side. That one will be a good idea. Good, let's do that. So I'm going to have something like this. Y will be equal to minus y naught divided by root of x naught plus y naught. So I think this is rather a good idea. Is that right? Yeah. So basically, let's have something like this here. Good. Let's solve for x-intercept 2 so that we can just add them together and see what we are going to get. But I was trying to simplify this and just thinking about it. Let's see how we can do. So let's go for s-intercept. S-intercept is when y is 0. So let's make y 0. So this will be minus root of y naught divided by root of x naught, x minus x naught. Is that right? Yeah. So this is going to give us minus y naught is equal to minus root of y naught divided by root of x naught, x minus x naught. So with this one, I want to make x the subject, so we can multiply this one by this and divide it by this. So this is going to give us plus. So let me just do it step by step. So first multiply through by root of this. So this is going to give us minus y naught root of x naught, which is equal to minus root of y naught x minus x naught. Then I divide through by root of minus y naught. So I'm going to have divide this one by minus root of y naught, same thing to this one, y naught. So this cancel that. So I'm going to have x minus x naught to be y naught root of x naught divided by root of y naught. Good. So what am I going to get? My x should be y naught root of x naught root of y naught plus x naught. But let's see, and let's see if we can just try to simplify something here, if that is possible. Okay, let's try and simplify some stuff. But basically, we can also just add, and then we are done. So let's just add, and then we are okay. So we just don't need simplification. The question is, we should find sum of x and y intercept. So this is y intercept, this is x intercept. Let's add them. So x plus y will be equal to minus root of y naught divided by root of x naught. And then, well, basically, we need to simplify that, because if not, we cannot do the cancellation. Is that right? Yes, of course. Okay, so let's do the simplification before we can do that, because this is not the same as that. Can you see that? Yes. So let's do simplification here. Now, this is the same as minus root of y naught times. Now look at this. We are using indices. A divided by root of a is the same as a times, no, a divided by a to the power 1 over 2, right? And this is the same as, this is to the power 1. So this is the same as a 1 minus 1 over 2. So this is the same as a 1 over 2. And this is the same as root of what? A. So when you have something like this, it's the same as root of that. Is that right? So it means that if I have x naught divided by root of x naught, this is the same as root of x naught. This is incredible. Or if we are using the conjugate aspect, I can multiply this one by root. I can multiply this one by this, and this is going to give me x naught root of x naught divided by x naught. This will cancel that, and this will be just root of that. So it means that this is going to give us minus root of y naught x naught plus y naught. And then the same thing happens to this guy too. So this guy is also going to give me s equal to root of y naught x naught plus x naught. Good. With the simplification from there. So now we can add, and then we can cancel some of the terms. Minus root of y naught. No, this is supposed to be plus because s first. Root of y naught root of x naught plus x naught. Yeah, we can actually combine this one in the one root, but no need. Minus root of y naught root of x naught plus y naught. This is interesting. How did we see that? This guy will cancel this. So we are going to have x naught y naught. So x plus y is now equal to x naught y naught. Is that right? Let's think of it, if this is right. Is that true? X naught plus y naught. So thinking about how this is true. Okay, so let's see if there is a short mistake somewhere. We are okay to go. So for For the x, we should have something like s naught plus x naught y naught, and for y we should have, oh, this one too should be positive. This is not true. Let's see where the mistake happened. Oh, okay. So I think the mistake was here. This supposed to be minus. Minus and minus is not good. So this and this will be positive. So this will be positive. Okay. So basically it means that this is not going to be going out. So this guy and this guy are not going to go out just like that. So we are going to have, so let me just combine them. This is the same as x naught y naught plus y naught, and this is also the same as x naught y naught plus x naught, right? So let me just combine it that way so that it can be very simple and useful. So x naught y naught plus x naught plus root of x naught y naught plus let me say y naught. So let's try and combine these guys, right? Let's try and combine them. So what can we do here? This can be written as x naught plus y naught plus 2 root of x naught y naught. Interesting. Now, how can you write this? Okay, so basically this is the same as, somebody will ask a question right now. This is the same as root of x naught plus root of y naught squared. Is that true? Yes, this is very true, because if I have root of x naught plus root of y naught times x naught plus root of y naught, then when I multiply x naught, root of x naught, root of x naught, I'll have x naught, right? And then this times this and this times this is going to give us this. And the root of y naught, root of x and y naught is going to give us this. Indeed, this is true. Then we saw that um, root of x naught plus root of y naught is equal to root of k. So it means that this is going to give us, so this is what we were looking for, just a k. Oh god, this is not good. So this is going to give us a k. So x plus y should give us a big k. This is not good. Wait, like, what can we do here so that we can just find a k? All right, so thank you for joining us out to this end. It's kind of a lot, but I think it's good for you to stay here. So I said I'm going to give you some information, right? So the information is that we are stopping here with coordinate geometry. So our next video, we are going to talk about circles, right? It's kind of interesting. We are going to talk about circles. When we are done with the circles, with examples, like some examples, and then what we are going to do is we are going to combine questions on coordinate geometry, these videos, and circles together, and we solve them with objectives so that it can prepare us for quiz, right? First quiz or something like that, so that it can help us homeworks, quiz, midterms, and those kind of things. We can work on those things. When we are done, then we are going to start, let me say the journey of mathematics, everything that you need to understand before you start your math. Limit, differentiation, and integration. It's very key. So we are going to start limit, differentiation, and integration after we are done with circles and solving examples and done with our quiz, right? Then now we move to those kind of topics. So before I end this with this coordinate geometry, I just want to give you something. As I said, all that you just need to do is you need formulas, right? So as I said, MERB series is having kind of formulas that you need. First page of the books, try and memorize them. Try even not like memorize. Try to understand the formulas, getting them, off head, right? So that you'll be able to use them, understand the questions when the question is given. This is how we need to go by that kind of thing, right? So basically, you just practice with some of the questions, and you'll be good, right? So yeah, I understand. Sometimes it's hard. Math is kind of you know it's difficult. It's difficult, but basically, it's one of the easiest. Yeah, let me say. I know when you are growing up, I mean, when you are going up higher, it's getting tough. But when you get the basis, that's the best way for you to understand all the additions that we are going to give it to you. Because nobody is going to tell you again equation of the line. You know it from this course. So you are solving, let's say you are in level 200 and you are dealing with vector algebra and you need the equation of the line or a vector, then you need to record the formulas that you've learned in this course so that you can use them. So basically, that's the idea of math. So you are building upon. So if you don't understand the basis, it's kind of so hard for you to go through that process. All right, so I will leave it here. In the next video, we are going to talk about circles. See you in the next video.